I welcome you to the second episode of the Science and Society series. So in this episode, we are going to discuss the scope of science. In the first session, actually, what we have done is that we said what distinguishes science from ordinary knowledge is one important fact, that science is verified. This is basically the test that science must pass. So what I'm going to do in this episode, I'm going to capitalize or develop this idea further and use it to determine the type of topics that can produce scientific knowledge. Some scientists and philosophers feel that science should be only based on observation and experimentation. So, which basically limits science to the description of nature. From my point of view, I don't think there is any valid reason for that restriction. Additionally, this stand or this position carries some negative implication. One of them is the exclusion of social topics. We shouldn't then consider social topics to do proper, reliable science. This is number one. And number two, when it comes to religion in particular, because it doesn't have that type of experimental validation that can be done in laboratories, that some people tend to think of religion as a subjective personal experience. So with that, we are in a position to list in more detail the aim of this session. Number one, I will argue that verification in essence is a reasoning process. And the steps you take in any experiment doesn't actually establish the conclusion in your mind. All what they do, they provide the pieces of evidence that you take and incorporate in the frame of reasoning in order to come up with the conclusion. So based on that, all types of knowledge which are subject to verification actually do qualify as science. So let's clarify that with a simple example. Perhaps the example you first hear in a probability class, which is flipping a coin. Flipping a coin, as you know, has two outcomes, either a head or a tail. And based on the fact that we don't control which will come out, that we consider it random. And we expect that if we flip a coin for 5-10 times, some of it will be head and some of it will be tails. However, let's imagine, just for the sake of discussion, that you flipped a coin for 100 times or 1,000 times. But it turned out that all the outcomes are heads. Will that make you think that flipping a coin is a deterministic process? I don't think so. A smart person wouldn't think that way. Why? Because as we said, the process has two outcomes which are not controllable by us. So, by definition, it is random. What made you realize that? Is it the experiment? No. If you go actually with the outcome of the experiment, you may go the wrong way and think that flipping a coin is deterministic. Actually, it is reasoning which allows you to realize, even before conducting the experiment, that it is a random process, just based on the setup of the experiment itself. Another thing, we know from the theory of large numbers that when we flip the coin for very large number of times, let's assume 1 million times, the two scores of heads and tails should be equal. Again, how do we know that? You have to realize here that limit is a theoretical limit. Actually, the experiment will never give it to you. Let's assume you flipped 1 million times, 500,000 are heads, 500,000 are tails. If you continue the experiment and flip more, the two numbers will again change. They may stay comparable to each other, close to each other, but they will not be the same. What allows you to have that realization, to think that at infinity, the number of the two scores will be equal, actually is reasoning. It is through reasoning, not through the experiment. Not through the outputs of the experiment you realize that. You realize that only through reasoning. We take the outcomes of the experiment and use reasoning to come up with something useful out of it. However, of course, when you One thing I wanted to say before that, sorry, you also have to realize to complete the picture that experimentation also have some inherent limitations. Experiment is a candidate of inductive knowledge acquisition. So no matter how many times you repeat it, it will never accumulate to formula in your mind. Let's take few examples. Consider a medical doctor who has practiced for 40 years. It is obviously very long period. Does that mean he has treated all types of illness? No way. He may have treated good numbers of them, but not all types of illness. The same applies to a police officer. He will never encounter all kinds of criminal violation. The same also applies for a manager. No manager has ever dealt with all types of personality. Does that mean all these people, when they deal with a new case, they will fail to handle it properly because it doesn't exist on their record of experience? Actually, no. They will take this limited experience and use reasoning in order to extend this experience and come up with useful laws. So we can here say with reasonable confidence that as long as knowledge has been verified within an acceptable frame of reasoning, it becomes a science. And there is no reason to limit science to the study of nature. But of course, when you apply this, you have to realize that every science has its own nature. So for example, when you apply the laws of motion in physics, which is the first thing we usually study in physics, you may expect some sharp, precise numbers, but don't expect the same, for example, from social sciences, because social sciences are stochastic in nature. They are not sharp, they cannot give you precise figures. Let's take an example, make a statement saying that people tend to be extravagant when it comes to their expenditures on wedding. Of course, as you can see, this statement applies to most people, but not all of them. You should be able to find actually few families who spend humbly in weddings, even lower than their social classes. So don't expect the statements or the findings you make in social cases to give you sharp numbers, the same ones you get in physics. But of course, this number should fall within enough range such that the result will be useful. The same thing applies to meteorology, which we discussed in the previous episode. Meteorology also studies stochastic phenomena, like the weather condition, the cosmic rays. All these things are random by nature, at least for us who don't know exactly the underlying mechanism behind them. Also, even physics, which is the typical example we give about how things can be precise and sharp, quantum physics tells us the electronic transition between energy level are spontaneous. Einstein said we should be able to know what causes them to go up and down, but up till now we didn't. So up till now they are stochastic. So even some randomness is accepted in physics. So the same way we accept randomness in natural sciences, we should apply the same to social sciences and accept that social science should give us some statistical results. When it comes to religion, religion actually is based on syllogistic deduction. Actually, syllogism is such a very strong way for proving things. You come up with two premises, and if you agree with the two premises, you have also to agree with the conclusion. That's how strong it is. There is no way you will accept the premises but say, then I cannot take the conclusion. It doesn't work like that. And actually, for this reason, syllogism is not always applicable to all cases. However, if you are lucky enough that syllogism applies to you, that means you are about to figure out a very strong conclusion, actually. So if the two premises happen to be axioms that follow common sense, undeniable, no one disagree with them, the conclusion also should carry very or should produce highly credible argument. That's actually what religion gives us. So actually the findings of religion should be more credible, should be more trustworthy than the ones we get from physics. However, some scientists are not very comfortable to invoke supernatural explanation when it comes to science. They don't want to establish the bridge between science and religion. And perhaps the reason for that is they are apprehensive that religion will tell them what to do or which position they should take. And it may be also going back to some historical reasons. We know how the church or how Copernicus was apprehensive about the reaction of the church toward his book. That's why he delayed publishing his book just a very short time before his death, actually. And we also know how the church negatively reacted to Galileo. All these things may have accumulated and triggered that position from scientists to have collaborative front with religion. But when it comes to Islam, actually the situation is different. And I would like to demonstrate that in 1 minute very quickly. Actually, Islamic theology divides being into 3 types. Necessary being, which is basically God, no one else. And impossible beings, like God associates. And then contingent. These are the things that may have existed or may have not existed. And the interesting thing is the whole universe actually falls into the contingent part. So the whole universe, everything in the universe actually can acquire so many properties. For example, flowers. They can take so many shapes and colors. There is nothing from logic or from religion that tell you they should take that color, for example, or the other. The same thing for birds. Birds pick their seeds in so many different varieties. There is no logical argument that supports this one or this one. Actually, people who study biology know these things very well. Actually, the feeding techniques differ a lot between all the animals, not just this. Regarding this one, the fact that creatures can take so many different properties, this is something actually you can find countless number of examples on it. So I don't need to keep going on it. The bottom line is the way the creatures are discovering their properties, their features, their function, this is left to natural science. There is nothing from religion to dictate here. And religion actually doesn't compete with science on this front. Religion has its own scope when it comes to guiding the behavior of humans. So I think for today, I said what I have. So thank you, and I hope to see you again with the 3rd episode.